this problem offers us a chance to look at inequalities, which is not one of the more common parts of algebra, although they come up and they're important. It says, consider the inequality shown below. And let me get my pen going here. We have this equation which uses greater than signs instead of equal signs. We're used to equal signs, but you can make equations with greater than signs too. And the important thing to note right at the very start of this is we're not looking at a single equation. We're looking at two equations sort of put together. And I'll just outline them here. This is one equation, okay? This right here where it says negative 13 is greater than 19 minus 2x. And here's another equation. 19 minus 2x is greater than negative 19. So if you're going to try and figure out which one of these statements is equivalent, it would help to think of the top statement as two equations in one. So let's try to solve them separately, and then we'll try to put it back together in one of these forms. Okay, so let's start with the left one. Negative 13 is greater than 19 minus 2x. Now you can use a lot of the same tools on an inequality equation, just like you would with an equal sign equation. I'm going to add 2x to each side of this equation. So I get 2x minus 13 is greater than 19. And then I'm going to add 13 to each side. So I get 2x is greater than 32, which means x is greater than 16 if I divide each side by 2. So let's put a box around that and just hold on to it. And then we'll come around here and do the right side of the equation next. I'm going to say 19 minus 2x is greater than negative 19. And I'll just add 2x to each side. 19 is greater than negative 19 plus 2x. And then we'll add negative 19 to each side, or add 19 to each side, I should say. So we get 38 is greater than 2x, which gives us 19 is greater than x. Okay? So I have 19 is greater than x, and x is greater than 16. Well, if you notice, all of these things are written as a single line, not two separate equations. So let's try and combine our two statements here into a single line. I'm going to put x, and x is in the middle. And what do we have here? X is greater than 16, right? So I'm going to say x is greater than 16, and x is also less than 19. So here's my equation. So let's look in this list and see which one of these is equivalent to it. Well, at first your eye might be drawn to this one, right? But if you look closely, those inequality signs are drawn the wrong way. It says x is less than 16 but greater than 19. That doesn't even make sense if you think about it. These other ones have different numbers, so they don't work. Although this one, actually, x greater than 16, that's an example of a gotcha. It looks close. In fact, it's correct in part of it, but it's not correct in the other part. It's missing the 19. So that's not going to work either. These other two have negative numbers. Those aren't correct. This one is actually the correct answer, even though it's not written quite the same way as ours. It's written backwards. 19 is greater than x, which is greater than 16. It's the same thing. It's just written in a different order. Now, that's how you go about solving this sort of equation. What I want to point out, as long as we're talking about inequalities, is something that is a common error which you may find yourself falling into during the solution of one of these equations. Okay, so I'm going to go back to this part right here. Let's say we had done this a little differently and subtracted 19 from each side. Okay, I'm just going to subtract 19. I get negative 32 is greater than negative 2x. And now you might say, oh, well, I'll just divide each side by negative 2 and have my solution for x. So you would think this means x less than 16. Well, if you notice, that's actually the opposite of what we get. X should be greater than 16, not less than 16. And the reason for that is this. When you divide by a negative number, the inequality sign has to flip over. And it seems like I've always thought it was an arbitrary statement. It was hard for me to remember that, which is why I generally don't divide by anything when I have an inequality. I take careful steps to avoid dividing by negatives in inequality equations, just so I don't mess myself up. I like adding to both sides. It's easier, and you don't ever run into this which way is the inequality supposed to be pointing problem. So whichever way works for you, as long as you get to the answer in the end, that's fine. Find a method that you're comfortable with. But I think the main point is inequalities like this have to be treated like two separate equations, solved separately, and then combined back together to figure out your answer.